Students, in this class, we will study about more on alternating current. And the first thing which we have in courses, we will study circuit theory. We will study pure resistive, pure inductive, and pure capacitive circuits. Okay, so let's start with pure resistive circuit. Okay, now pure resistive circuit is something like, if I take this, and this is a AC current, AC source, and this is okay. So this I can now in this loop, if I consider Kirchhoff law. So in this Kirchhoff law, I can say V minus IR is equal to 0, or V is equal to IR, or I can say I is equal to V by R, right? But we know one thing, what? Because it's a AC supply, V is equal to V naught sine omega t. Further, I can put it as V naught sine omega t by R, or I can say I is equal to I naught sine omega t. Okay, now remember one thing. What is the if I talk about the voltage, so what is the angle in the voltage? This, correct? What is the angle in current? Same. So if I talk about phase difference, then this is what? Phase of V minus phase of I, which is omega t minus omega t is equal to 0. Hence, I can say current is in phase with potential. Potential, right? Now, one more thing, just remember that, uh, here what we have done, this, if I write it this way, I have replaced it by I naught, which is the peak current. Peak current is equal to, peak potential, which is denoted by V naught by R. Okay, so that is what we used it here. Now, if we draw the phasor diagram of this, whatever we discussed here, I can draw it something like this. Let's say this voltage is this, correct? The phase of voltage is what? Omega t, correct? And because this is V, it will be what? This will be V naught cos omega t, and the vertical component would be V naught sine omega t, correct? Okay, now remember one more thing. If I talk about the current, see, V is equal to V naught sine omega t, correct? I is equal to I naught sine omega t, correct? If I say this, I know what? I naught is equal to V naught by R. So which is bigger? V naught is bigger, correct? So the I naught is actually in the same line, because it is at the same phase, but slightly smaller than V naught. Let's say it is somewhere till here. So this is called, this, if I talk or if I take it with a different pen, then this is I naught sine omega t. So this is I naught sine omega t, or if I write here, this. Okay, so this is I naught sine omega t, this is V naught sine omega t, correct? And both are in the same phase. So, you know, if we try to draw it in a very simple way, we can just draw this VR and I. VR and I. Correct? This denotes that both V and I are in the same phase. Now if I talk of wave diagram, right? We have done the phasor diagram, right? We have done the phasor diagram. Now we are doing the wave diagram. So for wave diagram, it is, we can write it this way, this, this, and because it's a sine wave, right? So first let me write this. This is T, correct? And this is V and I. So V naught and I naught in this direction, right? So if I draw it, thus the wave or the sine wave would be something like this. It's a sine wave. Now, if I talk about the current, so this is V. If I talk about current, we know what? I naught is equal to V naught by R, correct? Or I can say okay, so if you see here, you will see that I naught is smaller than V naught. So this I naught wave is smaller than V naught. So this is V is equal to V naught sine omega t, correct? And this is I is equal to I naught sine omega t. Now this is a bit smaller because if you see the the formula here, you will see that I naught is smaller than V naught. So this is the wave diagram, this is the phase diagram, this is the pure resistive circuit. So we have three things now: resistive circuit, phasor diagram, and wave diagram. Now the second case is, now let's take pure inductive circuit, and this is a sample circuit which I have drawn here. Okay, now in this circuit, if you see, this is an inductor of inductance L, and this is a AC voltage supply, and if you see by Kirchhoff's law, the direction of the current, let's say at any point, is this. Now when the voltage is this, as you know, what will happen? Inductor will oppose it, so the current will be built in opposite direction. Now if the current is built in opposite direction, then the battery would be something like this, because it's opposing it. So positive will be this side, correct? Now further I can write V minus E is equal to 0 by Kirchhoff's law. Kirchhoff's law, correct? Or V minus L di by dt is equal to 0. L di by dt is equal to V, or di is equal to V by L dt. Further, I can write it di is equal to V naught. I'm just putting the value of V. What is the value of this? Sine omega t, correct? Dt by L. Okay. Now after this step, let's integrate both sides. right? So when I integrate both sides, di will become what? I, correct? And this is equal to v naught by L, our constant, correct? Sine omega t is nothing but integration is omega t minus, so let me put minus here because it looks like v naught L, okay, by omega, correct? So this is further I can write now. What I can do is I can write or substitute. Let me put it by this pen. This as something like, I naught. So if I replace it by I naught, I can write it minus IO cos omega t. Correct? But I naught is equal to V naught by omega L. This omega also goes here. So this we have replaced as I naught. So I naught is nothing but V naught by omega L. Now this is something similar to resistance. Or I can say, let's give a new name to it and say XL is equal to omega L. This XL is called inductive resistance, inductive reactance. Inductive reactance, and the unit is ohm, because it's like resistance. Okay, very good. Now after doing this, let's talk about phase difference. So let's talk about phase difference. Now if you see this, so this is the final thing we got, correct? And I was minus I naught cos omega t. Now the problem is when I compare this with this is sine, this is cos, how can I compare? So it's a problem. So I have to convert this into the same form so that I can I can compare the angle between these two. Now to put it back, it's very easy. First, change cos to sine. So if I change cos to sine, I can say this is minus I naught, correct? And then I can say sine pi by 2 minus omega t. But we don't want minus here because we don't have minus here. So further, what I can do is I can write as I naught sine, I'm just taking minus inside because in sine it is allowed. It becomes omega t minus pi by 2. Correct? Now if I compare this, and this, I see that this is omega t minus pi by 2. So the phase difference is here. So phase is lagging behind by pi by 2 degrees or radians, whatever we can compare, right? So this gives a clear indication. Now one doubt students can ask, students might say that when we have taken minus inside, can we convert it into some other way? No, because what we want is See, this has sine omega t. So we want something in terms of sine omega t, not sine minus omega t, because then comparison would become difficult. So we have to try to make this and this as simple as that for comparison. Okay. Now let's come to phasor diagram. Now if you see the phasor diagram, let me draw it in this fashion. Okay, so in the phasor diagram, I can say that, let's say this is V naught, correct? If this is V naught, then what is I naught? I naught is lagging behind by pi by 2. So basically it will be something like, let's say here, correct? Let me put this up so that you can see. Yes, so this is I naught, and this angle is 90, and this angle is omega t, correct? This is V naught and this is I naught. Now if we have to draw it very simply, like, we can also say V and I, right? Or if you remember, if we go back, the phasor diagram of voltage and current in resistor was, in resistor was what? V and I. Okay, so now we will talk about the wave diagram of pure inductive circuit. Now if you see here, we know that V is equal to V naught sine omega t, which we found out. I is equal to I naught sine omega t minus pi by 2. Okay, right. Now to draw the wave diagram, let's quickly. Now think like this. This is what? T. And this is what? What is this? What is this? This is V or I. V or I. Correct. Now in this, first put t is equal to 0 because it starts from here. So if you start from V is equal to V, then this becomes sine 0 and this is here. So for the voltage, it would be, let's say, 2, 3. So for the voltage, let me not make it too big, but yes, I think it's needed. I can write that this is, and so on. Okay, so this is what? This is nothing but V is equal to V naught sine omega t. V is equal to V naught sine omega t. Now coming on to this, there is a lag of 90 degrees. So if you put t is equal to 0, then this becomes sine minus sine pi by 2, because minus comes outside. So this is I is equal to minus I naught. Where is minus I naught? Where is this is the max, this is minimum. So now the curve for this starts from here, goes like this, and so on. So if I have to draw it, I will draw it like, this curve starts from here, goes, and so on. Okay, I hope it is clear. I can mark this as I is equal to I naught sine omega t minus pi by 2. Okay, now the point to note here is when current is maximum, see the current is maximum. Where is the current maximum? This is voltage. Where is the current maximum? Current is maximum here. What is the potential here? Potential is minimum, and vice versa. So I can write that current maximum, potential would be minimum. Okay? Okay. Now this is the question. Let's attempt it. Now the question is, there is a circuit wherein we have an inductor of 2 Henry and there is a AC supply. The voltage is given as V is equal to 10 sine 10t plus 30, correct? And we have to find equation of current versus time, and also we have to calculate IRMS. Now the first thing is, let's solution. First thing, equate this with what? V is equal to V naught sine omega t plus phi. If you match it up, then what we get? Omega is equal to what? Omega is nothing but 10. Now we know I is equal to I naught sine 10t plus 30. I is always lagging behind by 90 degree. So minus 90, correct? Further, I is equal to 0.5 sine 10t minus 60. Okay, I can further write I naught is equal to V naught by XL, which we know. XL is nothing but V naught by omega L. Further, I can say 10 by 10 into 2, which is 0.5. Now, one thing to remember is, while applying this, make sure this holds true only when we are talking about I naught and V naught. This is not so, which are the peak current and voltage. This doesn't hold true if I don't put peak voltage or peak current here, because then you'll be rebounded back to the same thing, like which is 10 this phase, and there is a phase difference, there is a lag going in there. So again, let me reiterate, this hold true only when the peak values are in play. Okay,